Dear students, welcome back. In the previous session, we have discussed about smart Bristol-Faraday coils. So, in this session, we are going to discuss about multi-vibrator circuit. Okay, so the Faraday type currents were produced initially by the original Faraday coil and later on by the smart Bristol-Faraday coil. In the age of electronics, the current called the Faraday type current, which resembles the original Faraday current, is produced by the electronic stimulators, which containing multi-vibrator circuit. Okay, so this multi-vibrator circuit is one of the type of modifying current process that is called interruption. So the interruption means the current flow starts and stops at regular intervals. So such kind of interruption which is done by valve interrupter. So these valve interrupters are mainly works on the principles of switching action of the triode valve and the so-called CR timing circuits, and certain points regarding the wiring of resistance in series are all involved in the valve interrupter. So the same principles are involved in this multi-vibrator circuit. So before starting this construction of this multi-vibrator circuit, I want to revise the action of the triode valve now. So if the triode valve is connected into a circuit so that the anode is positive in relation to the filament. Okay, and the filament is heated, current passes across the valve. So the grid lies between, so this is the grid, lies between the filament and the anode. If it has no charge, it has no effect on the current passing across the valve, like this. Okay, so while if it is given a negative charge, so already from the filament the electrons are moving. So if it is given negative charge, the flow of electrons reduces. That means the current flow is reduced. Or if the charge is strong enough, in the grid, it stops the current across the valve. Okay, so while if the grid has positive charge, if grid is having positive charge which lies closer to the filament than does the anode, a variation in the grid charge has more effect on the intensity of the current flowing across the valve than does a similar variation in the anode voltage. Okay, if a sufficiently strong negative charge is applied to the grid, the current across the wall ceases, while if the grid loses this negative charge, the current flows again. Okay, so for this reason, this triode valve acts as a switch in the circuit. Okay, based upon the charge which is given to the grid. Okay, so please keep it in mind. So based on this only we are going to study this multi-vibrator circuit. Okay, now we are going to discuss about this wiring or the construction of the multi-vibrator circuit. So here in this circuit, two triode valves are used. Okay, that is valve 1 and valve 2. Okay, V1 and V2. These two are arranged in parallel with each other across the supply lines. These are the supply lines. This one is anode, that is positive, and this one is negative. So these two supply lines, in between these two supply lines, the valves are arranged in parallel. Okay, a resistance is placed between each anode and the positive supply line. So for every wall it is having an anode, isn't it? A1 and A2. In between the positive supply and this anode, the resistance are kept. These resistance according to this first triode wall and second triode wall. So RA1 is related to the first one, RA2 related to the second wall. Okay. In parallel with each wall, or a condenser and a resistance. So for each wall, condenser and resistance. So if you see this connection, the condenser and this resistance are arranged in series. Okay, with each other. That is C1 R1 and C2 R2. So one plate of each condenser is connected. So condenser is having two plates. One plate is connected to the resistance which is in series, and another plate is connected to the anode of one wall A1 for C1 and for the plate of C2 to the A2. Okay, so this is the arrangement of this multivibrator circuit. Now we will move on to the working of this multivibrator circuit. When the current is first switched on, it passes equally across both the walls. But a circuit of this type is very sensitive to interference from outside sources, and almost immediately some electron disturbances causes a variation in the intensity of the current across one of the walls. So this type of interference is similar to the which occurs in television reception. So we can find some variations in the pictures if there is any signals are not properly absorbed. So such kind of small variations normally occurs for this such kind of multivibrator circuit, because it is a very sensitive type of circuit. Okay, rise or fall in the intensity of the current flowing through either of the wall. So if any disturbances caused in either of the walls initiates the action of the circuit. Okay, only if any interference is caused, then only the action of this multivibrator circuit is going to act. Otherwise, it will have the normal flow of current. Okay. So first we consider if there is any change, if the change we will see in the V1, for example. That means if the change is a decrease in the intensity of the current of V1 because of those fluctuations which causes some decrease in the flow of current in wall 1, then what is going to be happen? So now we will see the sequence of events which are taking place due to decrease in the intensity of the current across the wall 1. Okay. In accordance with the principles of resistance which are connected in series, the potential drop between the supply lines, is divided between V1 and RA1 in direct proportion to their resistance. A decrease in the intensity of the current passing through the V1 corresponds to an increase in the resistance of the wall. Definitely, because if resistance is more, then flow of current decreases. So already the intensity is decreased. So in relation to the decrease in intensity of the current, what happens? The resistance is going to increase. Okay. Then And when this occurs, the potential difference across it raises. The potential difference across it raises. Okay, so where the resistance is going to increase, the resistance of the wall is going to increase. And when this occurs, the potential difference across it raises, and that across the RA1 is going to fall. Okay, the potential difference between A1 and the positive supply line is reduced. So the potential difference between A1 and positive supply line is reduced. Therefore what happens, and the anode becomes more positive. This A1 becomes more positive now. So what happens if it becomes more positive? The positive charge is transmitted through C1. So the positive charge is transmitted through the C1 to the grid of the other wall. So the positive is going to travel from C1 to grid 2. Then what happens? This G2 is getting the positive charge. So what happens to the flow of currents here? So because G2 becomes positive and anode becomes positive, now this flow of current is, that means the intensity of the flow of current is going to increase now here. Okay, that means and causes an increase in the current across the wall 2. This corresponds a fall of resistance here. A fall of resistance of V2 occurs. So the potential difference across V2 falls, and that across this resistance RA2 raises. Okay. Thus, the difference of potential between A2 and positive supply line is increased, and A2 becomes less positive now. That means it is more negative. So now the negative charge is transmitted via C2 to G1. So from this, the electrons are passing from C2 to G1, making it more negative. So again this G1 becomes more negative and further reducing the intensity of the current across V1. So then what happens? Again here this causes A1 to become more positive, and this passes again through C1, and it is passed to G2, and again here the flow of electrons increases and making this A2 more negative. So this series is going to continued. Okay, so again this causes A1 to become more positive, and the charge is transmitted to G2, resulting in further increase in the current across V2. Okay, A2 becomes less positive. A2 becomes less positive, and the negative charge on the G1 is again increased. The process continues. How much a time this process is going to continue means, the process continues until G1 is so negative that V1 ceases to conduct. Okay, so that means this will continue until the complete stoppage of the flow of electrons takes place in the V1. Okay, so A1 is then at the same potential as the positive supply line. So G2 is more positive than at any other time, and V2 is transmitting maximum current. This is the switching action of the walls, and the series of events occurs instantaneously. The circuit is then stable with one wall cut off and the other fully transmitting. So that means now in this case wall 2 is transmitting fully and wall 1 is cut off. Okay, so the condenser C2 is in parallel to V2. Okay, and so the potential difference across it is the same as that across the valve. It is charged at the beginning of the action, the left hand plate being negative and the right hand plate positive, but during the above sequence of events, the potential difference across V2 falls, and so that across G2 also falls. C2 therefore begins to discharge through R2 and V2, and its left hand plate gradually loses its negative charge. The grid of E1 is connected to this plate with no resistance between, so is at the same potential as the condenser plate. So thus, as the condenser discharges G1 also loses its negative charge, and when charge falls to a certain level, V1 again begins to transmit current. Okay. So the time that lapses before this occurs depends on the duration of the condenser discharge, which is determined by the product of capacity of C2 and the ohmic resistance R2, that is C2 into R2. When V1 begins to transmit current, the switching action is again brought into play, but acting in the reverse direction. Then what happens? V2 is going to cut off and V1 is going to transmit fully. Okay, so this is the working of this multi-vibrator circuit. And here the current supplied to the patient, in this case the patient circuit is wired in parallel to the RA2, that is this resistance 2, and the interrupted current flows through this resistance is also supplied to the patient. Okay, yes. So this is the function of this multi-vibrator circuit. Okay, so in the next session we are going to discuss about the sinusoidal currents. Thank you.